proud to be presenting today on the integration of two of the best technologies, FileMaker and Node.js. I'm also proud to say that this is not my first time on the presentation stage at DEF CON. Some of you may remember the amazing presentations we had last year. There is one from my friend and mentor, Mr. Chris Hippolyte, that I remember very well. Thank you.
Oh, everything's off.
Hold on.
Yeah, go ahead. Ladies and gentlemen, Louis. So I was about to thank him, so I'm glad he could actually get up here and get an applause.
So it was actually at DEF CON that a friend and client came to me for help solving a problem. They had applications that they were deploying that had a very robust syncing mechanism, but they needed a way to tell when they were connected to a network. They needed to know what network they were going to connect to at what particular time. So this presented a particular very challenging problem. And there were a couple objectives that we needed to make sure that we solved in order to do it right. So we needed to provide real-time communication with a standalone FileMaker application. Standalone meaning that the application is offline. It's not connecting to a FileMaker server except for when it needs information. We had to trigger changes within FileMaker Go and allow the user to remain aware and provide feedback for loss of a server connection. If the server was offline, we needed to communicate that to a user, save the information so that later on when they were online, we could pass that information back to the server. We also had to sync information between FileMaker server and Node.js using the data API. So let me show you a quick demo. Chris Hippolyte over here. Don't worry, this is recorded. So what you have here is a hosted solution. This is a solution that would live within a network. It's got a list of users, some rather familiar to me. And what it actually does is it allows us to see the state of each particular user. We have the user's name, the last device they were connected to. We have their connection ID, should they actually be connected, and the current state of the application. You'll notice everyone was offline in that case. When I start up the Node server with a node source command, and we're going to get into that in a little bit, I can then open up the socket client. We're going to see that in a second. So there's a slight delay as we bootstrap the web application. The device sees that it's connected to the network, and in just a moment, it's actually going to communicate this to our server, letting me know that I've just logged in, I'm on my iPad, and I have the connection ID. In this particular case, you can actually see the Node.js application has started to communicate with my server, authenticating and then updating the record as I go. And if I like, I can actually simulate shutting down the application, and we can see the UI in the client application update pretty close to real time. It's not exact, but it's very close. I can then start it back up, and we'll see that the application should come back online after a connection is made. So we have this feedback for a user, letting them know what network they're connected to. Similarly, I can simulate the loss of a connection within the dispatch by clicking a button within the socket application, letting them know that I'm now offline. So pretty straightforward, but it's real-time communication between FileMaker solutions that are not hosted, or at least one that is not hosted. So there's actually quite a lot to this system. There's a few different subsystems that are working together. And let's take a step back and look at the system as a whole, and we'll dive into each particular area and see how they function. Moving from the left to the right, we have a mobile application that will communicate to our FileMaker server via REST communication, aka the data API. We also have the mobile application that will communicate to our Feather server, and we'll do so with a WebSocket connection. The Feather server will then communicate to FileMaker server via either XML, if you're familiar with Todd Geist FMS XML connector, or the data API, whichever you choose. And then the FileMaker server will host a file that users within a network would use as you typically think of a standard connection. So this is the standard connection. We're using FileMaker Go or Pro to connect via a hosted file. With this, we're monitoring the state of devices used in the field. And we're providing a highly customized application that is easy to maintain. And this part is actually kind of critical. The Node server is great. It allows us to have some great event-driven interactions, but it's actually really hard to maintain. The IT support is already in place to maintain FileMaker Server, so we want to do all the customizing of the application within FileMaker whenever possible. Moving out and heading to FileMaker Server, we see that FileMaker Server, of course, provides service to our desktop applications, our non-mobile applications, via the standard connection. It provides state to Node.js server and our mobile application, letting the server know what's going on both within the dispatch application and keeping track of what's going on within the client application and updating things accordingly. And optionally, if you like, if you're in an environment that supports this, you can actually host the embedded application we're going to build later on within custom web publishing. This would be applicable if you were in an area where you weren't dropping out of an internet connection and you can rely upon it. This makes integration much, much easier. Moving from FileMaker Server, we're going to jump to the Node.js Feathers server. Hope some of you have seen Feathers server both from Todd Geist's talk last year and also his advanced class this year. The Node.js Feathers server will communicate via socket connections to the embedded mobile application. So we're going to use socket connections to speak to a web application. It's going to communicate device state to FileMaker Server. So when a user logs on, it's going to communicate that to FileMaker Server. If a user were to send a message, it's going to communicate that message to FileMaker Server for the users on the other end to actually take a look at, decide what they're going to do, and then move on. Finally, we're going to pass messages received from the mobile application back to FileMaker Server. Within our mobile app, we actually have two applications. We have the FileMaker application that's going to support our application logic. This is where our business logic is going to live, and data storage. This is where the information is going to be stored. This allows us to maintain the application offline. We don't need an internet connection. We can communicate this state to FileMaker Server via REST, the data API. And we can export and host a socket application, which we're going to see later on, so that if we did want to maintain our state offline and not have an internet connection, we can still maintain that web application. The next application is actually embedded within FileMaker Go or Pro, the client side, and that is an Angular application. In fact, the original socket communication that we built wasn't built with Angular. It was actually just pure JavaScript. And I mention that because it's actually rather important. There are some hurdles that you have to overcome if you're going to put an application like Angular into a web app. Most notably is security. If anyone has noticed, between 15 and 16, there's been some security changes. So you have to be really careful what files you read from the local directory and when and how you read them. Most notably, if you're running on Windows, calls to a local directory can be severely restricted. But inside our Angular application, we're going to facilitate communication via sockets to our Node server. This allows us to use an event-driven paradigm, which we're going to get into in a little bit. And we're going to provide mobile application state to Node.js instance. We're going to let the Node.js instance know what our FileMaker application is doing at any particular time, and also communicate messages from the Node.js instance back to FileMaker using the Angular application. So we're actually going to do this using the FMP URL script, which we'll see in a little bit. Cool. So that is the overarching architecture of our system. It's actually a few systems put together. And this kind of begs the question, why a web application? Why are we going to go through all the trouble to bootstrap a web application, or actually write a web application, bootstrap it, embed it within our mobile application, and then use it? Well, for me, it allowed us to use an event-driven paradigm. This paradigm works very well in messaging-based systems. And what I mean by an event-driven paradigm is, something will happen, aka a socket will make a connection. It'll emit an event. Our web application is able to read that event and then trigger a script within FileMaker. So really quickly and really easily, we get the ability to trigger events within FileMaker that are non-blocking. So one of the biggest things for me also was that the user experience doesn't suffer. Because the web viewer is non-blocking, if it calls an FMP URL and the system is busy, that URL is just discarded, right? We can deal in the web application with maybe sending that message again when the system isn't busy. We don't have to continually poll over and over again a particular script trigger. So how do we go about bootstrapping a web app within FileMaker Go, right? We have web technologies that we can build, and we want to actually have an application live within FileMaker. We do that by first exporting our files to the temporary directory. So normally this is done with an on-window open, where we create a global variable, and then we point a web viewer to that global variable. In our case, it would be temporary directory / index. Later on, we'll see that we can actually modify this variable without having to reload the web application. So how do we go about building a web application and a Node.js socket communication? Well, we're going to do so with two tools, the Feather CLI and the Angular CLI. These systems are very complex, but one of the great parts about these CLIs, with the links that you see there, are that it allows most of the boilerplate code. The code just goes into supporting the applications and supporting the server to be generated for us. That's going to allow us to focus on just the quick and easy portions that we need to do for our specific business logic. In our case today, that's going to be watching for socket events and communicating back to FileMaker Server for a web application, connecting with the data API from Feathers to our FileMaker Server, and sending messages back and forth. So here's an example of what you would do with the Feathers CLI. It's really only 5 commands. The Feathers CLI, first thing we have to have is NPM. Luckily, NPM is bundled with Node, which is also bundled with FileMaker Server. So if you're looking for a copy of Node, you can go no further than the FileMaker Server installer, and you have a copy. There's 5 commands here. The first thing we're going to do is install the application. We're going to then create a directory, go into that directory with cd. We're going to generate an app, and then start it up. So let's dive into some of the custom logic that would be created after this happens. So here's an example of the socket logic. Using this logic, we will connect with our Angular application, and I'll highlight the important aspects of the code with colors. Blue are events our server will be watching for. Red are actions our server will take based on those events. And brown is a type of events that we're watching for. So blues are actions. You'll note that they're all called on, right? Brown is the type of event that we have. And then red is the action we're going to take based on that event. In our case, we're waiting for a socket connection. When we get that socket connection, we're going to emit an event. That event is the status request. We want to know what actual application connected to us. Then we're going to listen for 2 other events, the status response, which would be the response from the event we just emitted, and the user information, right? What user is actually using this? In the case of our demo earlier, we got the device of my iPad and the user of my name. So when either the status response or user information is created, Feathers will take the appropriate action. Although this may look a little bit different than what we're used to within FileMaker, it's actually not all that different than script triggers, right? You may have done things like this before, maybe like an on-commit. On-commit record, take an action. So there's really not much difference here. It's really just verbiage. So we have this logic. We're taking actions. We then need to look at what actions we're going to take. And that is going to come in the form of a hook logic. Feathers is a very cool server application in that it allows us to create hooks before and after particular events. In our case, we want to hook into the device create, and we want to hook into the device update. And we're going to do that in order to authenticate to our data API. As hopefully most of you know, when you're communicating with the data API, you need to do so with an authentication token. So that is one request you have to send out before you can send out any additional requests. So we're going to handle that with a Feathers before hook. This hook goes into all our Feathers actions, and it's going to send out a request. And just like we saw earlier with our socket logic, I've color-coded them. So we have our main function, which is in purple up at the top. It's FM login. We're going to log into the data API with this call. And that's going to return something which is called a promise with a request. And then it's going to do something or catch with an error and reject. So here we're defining a function which can be used called FM login. You could think of this as a custom function within FileMaker. This handles the logic. The logic that it handles is all within one area. In fact, we're not even passing it any variables in this case. It's just doing something. And it's going to return information once it's called. So every time we make a request, whether it be to update or create, we're going to go in. This request is going to fire. If this request fires and it resolves with a parsed response, we're going to move on and then create or update our record. If it rejects with an error, we're going to say either send an error back to the web application or maybe we'll try again later. So we've successfully authenticated. We're then going to move on and try to create, or in this case, update a record. And we're going to do so, again, with the data API. Now, this is a little bit notable. We'll take a second and look at this. Again, it is color-coded, so the same colors apply. Here, we're giving Feathers a few things. We're giving it a URL, which is the URL for our hosted file. We're giving it a content type, which is application, JSON. We're giving it our data token, which is what we just got from our hook. And then we're giving it a JSON, which we're stringifying, meaning we're turning it into a string, of online and the device ID. So in this case, our application has booted up. It's connected to our Feathers server. Feathers received that event. It went in and said, OK, I've received that event. I'm going to use my hook to authenticate. And then I'm going to update a record, telling the record that I'm online and that this is my device ID. The next portion of this is done with the Angular CLI. We've covered how you actually go in and create records. Now we're going to go in and showcase how to communicate with FileMaker in the mobile application. In this case, though, unlike the Feathers API, we have two additional items. We have the NGG service socket service and the NGG service FM communication service. And it's important to note here that as much of our logic as possible isn't going to be here. As much of the logic that we're going to build is actually going to be in FileMaker. What these two services at the end actually do are just call FileMaker scripts where we can update our UI logic or create or edit a record. So let's take a look at some of our logic. Within Angular, we have two pieces which are fundamentally important: send user information and listen for server. Send user information returns a socket.on. Again, this is part of the event that we saw earlier. And then emits user information. So this is the response that we saw earlier. We had Feathers ask to send us information with a user request. When we received that user request, we're going to emit the user information of Lou and iPad. Similarly, listen for server is going to listen for a status request, just like we saw earlier. And when it receives that request, it's going to call something new, something we haven't seen yet, and that is the FM communication.callFM. This is the FMP URL trigger that I mentioned earlier. It's going to take two parameters. It takes a check connection and a parameter of data. This is done so that we can actually go in and change what scripts we're calling based on what event. We can change what data we have based on the context of a particular user. You have a question? What's that? Yes. I mentioned that at the beginning. Maybe I didn't mention it at the beginning. The source code for this will actually be available on GitHub. The link's in the very beginning and the end. Awesome question. Thank you. It's hard to see it out of context. We're going to do that one next. Good question. So let's take a look at send user information and the emit command, and then we'll take a look at the FMP URL. So that was the socket service. In this case now we're looking at the communication service, the portion within Angular that's actually going to call our FMP URL. And in this case, we're looking at construct URL. This is going to take some information from call FM, and it's going to construct a URL that we can then send back to FileMaker. In this particular case, we're taking script parameters, as we saw earlier. We're going to return a promise, and that promise is going to be the FM script call, and that's going to be the base URL, the server, the file, the script parameters, and the script name, all bundled together. And when it's complete, you'll see it down at the bottom. In this case, it's going to generate FMP $socket.fmp12 with the script of drop connection. Actually, that should have been confirmed connection, not drop connection. It's a little off. So another very important aspect of the Angular functions that we're creating is a route change. I mentioned that we want to actually create most of our logic within FileMaker. That then begs the question of how do we communicate between FileMaker and our web application? Well, we're going to do so by watching the URL hash. When we bootstrapped our application, we got the temporary directory. We made a slash and then an index.html. We combined it together in a global variable. And now we're going to append to the global variable any information we want to send to our server or to the web application. In our case for this, we're actually going to send the settings, who I am, the device that I'm on, my connection ID. So I'm watching the route with a hash. I'm responding to those hash actions. So when the hash changes, I'm responding to it. And then I'm doing something called a subscribe. And we haven't actually seen that yet, but we're going to see that in a little bit. What it basically means is I'm going to watch the hash for changes. Anytime there's a change, I'm going to populate that change to any function that needs it within my service. So we'll circle back on subscriptions and the observer pattern in just a little bit. Let's take a look at how we update our application's URL from within FileMaker. So we know that we want to update our URLs. We want to update the hash. So within FileMaker, we have a particular way to do that. I think it's rather clever. It's something that I enjoy very much. And that is the set variable with an evaluate of a let statement. The idea here is that we build a let statement. Notice that it's actually text. It's not a full let statement. And we're saying that the application URL, that's our global variable, will equal whatever the application URL was before, the hash symbol, and then the hash data. So when we actually fire this, the evaluate is going to take the let statement, make it into a real let statement, which is going to take the global variable and make it into something that you see at the bottom, which is HTTP, temporary directory, index.html, hash, and then send message to server, and then presentation's almost over. So in this case, Angular is going to receive this URL. It's going to take the corresponding action of send message to server and populate it down our observer pane. So that question is, well, what is an observable? What are we populating down? And what do I even mean by a subscription? Well, I could try to explain it to you, but I find that it's actually a lot easier to show you. So what we have here is a message along a timeline. And what I'm going to do with each of my functions is I'm going to subscribe to a message on my timeline. So I have a few functions that are subscribing. As a message comes in, it's going to go to that particular subscription and trigger an action. The great part about this is it's not combustible. It doesn't actually remove our message. The message is always going to continue down the stream until everyone's received the message. Now, in our case, one of the great parts about this is that we can do multiple things with these messages. We may start with one timeline, but we may use multiple functions and multiple mapping to actually take different actions depending on the message. So in this case, I have a message which triggers an action. I have a message which triggers another message. That message could be subscribed to something. And finally, I've populated all my messages and all my actions from one particular emit, one particular socket emit. I had two messages and one action. Cool. So what does this actually look like? We saw earlier that we could update status information, but when you start talking about messages and you start talking about sending things back and forth and taking multiple actions, it kind of begs the question of, well, what else can we do? We don't just have to stop at updating UI. We can send information back and forth. In this case here, we're going to send a message from our dispatch server to our socket client, and then from our socket client back to our dispatch server, hopefully as real time as possible. Hopefully the message is received. Should be. Yep. Message is received from dispatch. It does take a little bit. It's not exactly real time. We then fill out a message within the dispatch application. And it's received by the dispatch application. So we're receiving real-time communication with applications that are actually not connected other than through this node service. In this particular case, we just did messages, but the real goal behind this would be to trigger an API call. So the socket client is offline, it returns online, it checks with the server to see how much information it's missed, maybe via change token. With that change token, it sends it to the data API, receives the information, and we've then updated the application. So I've run through my presentation very, very quickly. This is, again, my first presentation. But I do want to let you know that all the source code is available online. That's my GitHub. So you can actually see it within context. I do have plenty of time for questions since we're only about halfway through. There will be session updates for this. Oh, here. There you go. Any questions? Go for it.
Can you show it? Louis, can you repeat the question?
Yes, he asked to see the actual code, which I have plenty of time. I went through this very quick, so I most definitely can. So this is the Feather server. Again, 90% of this code is actually automatically generated with the Angular CLI. The one portions of the code that we did create together is actually here. Here's the IO.connection. In my case here, just for dramatic effect, I've logged out that a device is connected. I'm then emitting a socket event of registered device. And then I'm listening for a device response and a message to pass that message along to my FileMaker server. I'm also going to socket.on to confirm the connection, where again I log out that the connection is confirmed, with the parameters of the device is online and the ID connection of whichever connection I happen to be on. You can't see it. It's actually right there. I should update it. So socket ID, device name, username, and data. Then I'm moving to device.update, which we saw earlier. And that is actually in our services. So in this case, this is the create that we saw earlier. When a device is actually logged on, the first thing it does is actually create a connection. And that's done with the data API. Again, you see there we have the HTTPS, iSolutions.fm, the URL. The method is post because we're sending information within the body. It's calling it the data token that's generated with our hook. And then in our case, because the data API doesn't allow us to call IDs directly, we're making one call to actually find out what record we need, what record ID we need, and then we're making another call after that to actually update it. So there's actually two calls that need to be made here. Go ahead. Say that again? This is not up yet. This will be up at the end of DEF CON. So in our case, we're first looking for the record, and then once we have the record, we're using the parse response ID to actually send it out. Any other questions on the Feather service? Go ahead.
So this code is running on your FileMaker server box?
Well, in this particular case, it's running locally, but if I were to put this into production, I would run it on an AWS instance, most likely CentOS.
And then on the client side, what handles the socket communication?
On the client side, if you mean the application, is the Angular web app. FileMaker Server doesn't handle any of the socket. That's what Feather is for.
Run inside a web viewer?
Yes, inside a WebViewer. Yeah, we're bootstrapping a WebViewer.
And you have to have that web viewer on all the layouts?
You do, yeah. You do. So this is our socket application. We saw this a little bit earlier. I'm not really going to go over the HTML portions, but I will go over the services since you did see them. There were two in particular we generated. We generated the FM communication service and the network service. The FM communication service is obviously the larger service. We're importing a few different modules. In my case here, I've spaced them out to just make it a little bit more readable for everyone. We're importing things like FM settings, which is a class, a user, which is a class, and script parameters, and then finally our network service, so we can make calls. When we actually bootstrap this service or inject it into our component, we're doing so by first constructing the things we need, reading from a particular file, in our case, a settings.json file and a current user.json file. To answer the gentleman's question earlier, this is how we get that information if you weren't using a hash. In our case here, and we'll see this in a little bit, what we're doing is we're telling the application via the hash what file to go to within FileMaker. It's reading from that file and then pulling out the information. Again, there are security concerns here. You do have to be really careful what files you read and when, particularly on Windows. If you're going to be in a Windows-heavy environment, I wouldn't recommend using files at all. I would recommend just using the hash. So here's our call FM script, which we saw earlier. This calls the construct URL, which we wrote together, which creates an FMP URL, and then actually calls it down here with, in my case, I'm logging it out, but window.location.assign constructed URL. What this allows us to do is basically take the constructed URL we did, put it into the web viewer, and then rapidly move back to our application. This is important because we don't want our application to keep reloading. The other way that you'd have to do this if you weren't subscribing to the hash is to actually change the URL, reload the application, and then look at the URL again. But because we can use an evaluate let statement within FileMaker, and because we have the ability to subscribe to hash changes, we can update on the fly our hash, and the embedded web application will just read that subscription. So, and this is actually a good example. If I were to rewrite this again, I would actually use UI router instead of just hand coding the routes. But in our application here, we have the ability to update the app via hash, update the app via a file, read the data, and send the message to the server. Those are the UI actions, UI route actions that I've actually encoded here. But again, if I were to write this again, I would write it with UI router. The network service, when it gets injected into our component, takes the user and then the FM communication service. One thing I'll note here is the FM communication service, if you were to do this at the same time, if you tried to have a component that I would read from both the FM communication service and the network service at the same time, your application would fail because you basically have circular logic. You have the FM communication service, which is relying upon the network service, and the network service, which is reliant upon the FM communication service, so you'd never actually be able to bootstrap the application. So you do have to call them at separate times. In our case, we're connecting to a server. We're going to the URL that we read from our settings file. We're saying on this URL, we're setting to secure false just to make it easier to connect. And we're looking for a socket.on, a server response, or a socket.on registered device, or a socket.on message. We saw these earlier. Finally, one interesting thing we've done is monitor connection. There's actually two ways to monitor a connection within socket.io. One which is available to Angular and one which is not yet, but they're working on. This is actually using interval to poll. So basically every 5,000 milliseconds, I'm going in and checking to see if I have a connection. If I have that connection, I'm sending a confirm connection script to FileMaker. If I don't have that connection, I'm sending a drop connection to FileMaker. That's one way, and I find that that's actually the less elegant way. The better way to actually would be to check the socket connection, which is done with a this.socket.connected action, but that's not yet available with the library that I'm using. Any other questions? Go for it. It does. It does, yeah. Everything is very, very layout dependent, which is the downside to having non-blocking actions. We don't have to continually pull with a script and block users from doing things, but we are relying upon having a web viewer on our layout in order to communicate back to our socket service. Good. To the Feather server? Or the service, the FM communication service? Yes. Yeah, so the RxJS is actually for the, well, it's for the subscriptions. Promises, I believe, are just native here because it's TypeScript. But if I were to do this outside of this, I would use Bluebird. So in this case, I'm importing RxJS just for subscriptions and the observer pattern. This is written actually in Angular 2, not Angular 4, when you still had to actually import RxJS in order to use it. Similar to that question, I'll add to that, is with network service. I'm importing socket from ngsocket.io. That's the old method of doing it. Now you would actually just import star from, I'm actually blanking on the library, but the newer socket library. So this has actually been evolving. It's one of the reasons why I said, again, if you don't need to use Angular for this, you can not do so. Or if you want to use something else which is a little bit more stable, you can do that as well. Yeah, and actually, as I said in the very beginning, the initial version of this that I wrote wasn't written with Angular at all. It was written just with pure JavaScript, and that was a security thing. It was because at that time, Angular 4 wasn't out. It was only Angular 2, and it was actually, I believe, still in beta. It wasn't actually fully out. So I had the option of either using it and trying to make it work or just using JavaScript. In my case, because I wanted something that was going to be production ready, I used just pure JavaScript. In this case now, I'm using Angular simply because it allows me to watch my hash a lot easier than it was earlier. It was a lot harder using pure JavaScript to watch my URL hash. And then I get to use subscriptions and observers, which for me were very cool because I could actually chain things together. That's how I'm actually able to do messages. Messages are a socket that I omit, but I'm actually omitting the socket, where I'm reading that socket, and then I'm firing a message based on that. So that's the advantage using Angular. But again, if I would use JavaScript if you're just looking to go to production, not to test some of this out. It's actually not a performance issue at all, really, because there's not much code there. For me, it was twofold. Every time you reload the web viewer, you're making another connection to your server. So you then have to write the logic to say, like, no, you've already connected. I don't need to make another connection. And B, why reload it when you can not? Why reload it when you can just go directly to the hash and keep it, maintain your state? In this particular case, we could probably get away with reloading it, but if you were to make, like, say, a web calendar, you don't necessarily want to reload it every time you update information in the web calendar. You want the information to just persist. Awesome. Any other questions? Thank you.